Hi. My problem is one of my revolvers has, over the passage of time, lost a critical part. Specifically, what, for want of a better phrase, I'll call the cylinder spindle, which is this piece here. This is from a Webley Bulldog type revolver. As you can see, it's bored completely through. It's got some crescent cuts. The barrel sits on top of that like that. It's got a flat end on here. The hole in the center is 1/8 of an inch in diameter. And the gun is basically non-functional without this piece, which holds the extractor. The solution is to make a new one. To manufacture the new one, what I've decided on as the starting point is a standard industrial type hexagon bolt. This is a grade 3 bolt. I feel that would be sufficient because the spindle around which the cylinder revolves has no real strength requirement. It just needs to be made of steel and hold the extractor in the center. To accomplish the task on my lathe, I have rounded off here the hexagonal face of the bolt. I have smoothed the bolt face. You can see I've got done pretty good as far as zeroing out the lathe so that it's running centered. I've got about would that be 0.001 inch of movement or deflection on the lathe. I will now be drilling out a hole in the center, which I've already started, but basically we'll be going in like that and drilling it out so it's through and through. Next we'll be pulling the bolt back out, and on the lathe cutter we will thin the outside diameter of the bolt down to something more akin to this outside diameter, and the work progresses. The hole drilled, it will now be reamed out to the 1/8 inch diameter with a straight reamer. Let's see. And I believe you get the idea. So what I have now is a bolt 4 inches long with the hole going right through it. I'm presuming you can see the daylight on the other side. It was initially bored out to 7/64 of an inch, and then it was reamed out to be 1/8 of an inch. Not too bad a job of centering. The drills tend to drift a little bit as you go deeper. The length I need is right about here. So my thought is, while it may be a 1/16 of an inch off or less on dead center in the final 2 inches, once I cut it in half at about here, I should be pretty close to dead center on both ends. And like I say, she's already been reamed out to 1/8 of an inch. There you go, I see the flash of light. So you can see she's bored completely through. And it's a true 1/8 inch all the way down. Next step is to put it back in the lathe and make it thinner and reduce the thickness of the head of the bolt, or what used to be a bolt, for want of a better phrase. That's all. Okay, the new shaft for the cylinder obviously requires a diameter of not more than 0.485 inches, 0.2485 I should say. And here is the bolt that we were working on yesterday. As you may be able to detect or notice, it is now quite a bit smaller than it was yesterday. Specifically, it is down to 0.29 inches, which means, of course, I have less than 5 calibers to go before it's at the final dimension, and I figured I'd give you guys a chance to watch some of the cutting, which is now engaging. I can speed it up a little bit for you. Figured I'd show you how I handled that back end. You'll notice the removal of a piece of thread. I could speed it up a little bit for you, but get the idea. In this fashion, the entire bolt has been reduced from an initial dimension identical to this one, and the reductions will continue until I have something very similar to this little piece here. And obviously, we've only got a little ways to go, and soon we'll have a replacement part. End video. I'm doing this one-handed, so bear with me on some of the camera angles. This is the revolver that's missing the shaft for the cylinder. One of the advantages of the Webley Bulldog pattern and the Webley RIC pattern is there were so many of them made, it's pretty easy to find alternative specimens to use to copy a pattern on. The dimensions may vary a little, but the shape will remain the same. This particular cylinder shaft and extractor is from a different revolver of the same class. One of the features of these that you should note is that half moon crescent cutout. The purpose of that is to fit against the barrel. The barrel in this particular instance, when I measure it, has a diameter. Give me a second, I already know what the answer is, but give me a second here, one-handed. Okay. The barrel dimension is 0.61 inches. 561, of course, is the same as saying 79 1/28, which is also pretty close to 15.59 millimeter. Let's run with 79 1/28. We'll add 1/28, which of course will make it 80 1/28. Cut that in half, that becomes 40 64ths. Cut that. When we measure the barrel, let me put this down a second. You can see this occurring. When I measure the barrel, I come up with a dimension. I want to measure it sideways. Bear with me a second. (39/64) was 79 1/28. Depending on, yeah, that's a lot of difference there. Maybe. There we go. 5/8 of an inch. 5/8 of an inch means that I will be able to take a 5/8 inch end mill, and I will be able to just cut into the crescent here and make a notch identical to that on the other cylinder shaft. The purpose, of course, will be to provide something for the barrel to rest against when the weapon is being fired. I will also thin down this little ring right here, which I left for purposes of making an exact fit. I will thin that down so it's an exact fit to the revolver. That's all. Putting the 5/8 crescent in. Smoke is the cooling oil, the cutting oil, reducing the friction. You get the idea. Necessary cuts made in the spindle or cylinder shaft or whatever. The next issue is one of length. Obviously I'm going to have to shorten this by about a finger thickness so that it sits flush. But for right now, good job. The piece now fits into the gun, so the next step is to polish that shaft, for which I'll simply use the expedient of sandpaper or emery cloth, and just back and forth and take any rough spots out. Final part of this will be to open up the extractor groove to a dimension of 9/64 inches. I will do that with the straight reamer, and after that I will flame glue this part. Okay, this is a test of the part I constructed from that big bolt, and let's see if I did my job right. And slide that in here and line up the cylinder thusly. Drop the extractor back into the groove. There we go. We have a functional 19th century revolver. The only correction I need to make is, I don't know if you can see this, but right here I've got a little piece I left out protruding, about no, 1/8 of an inch. I'm going to have to file that down so it more closely matches the contour of the revolver. And of course I will flame blue these, and I will put little serrations in them later with a Dremel tool to make them easier to grab. For right now though, this revolver is restored to function, and this will look much better once I get the I'll probably trim this back on this side also and trim right there, but essentially the part is made. It's the piece after it's been flame darkened. It's no longer the same white color it was before. This light is deceptive, but really it's much darker than it looks here. But anyway, I pronounce it done. For our next project, building a .22 caliber pistol out of a bolt. And obviously we'll put a nut at the rear end of it with a snap hammer, and it'll be a .22 rimfire.